Hello, my name is Magnus, and I like writing T-SQL code that runs fast. And to be able to write T-SQL code that runs fast, you most often need to apply a set-based approach to whatever problems you have at hand. In this video, I'm going to demonstrate how to use a tally table or a numbers table to generate time slots. And I've seen many examples. I do training on T-SQL courses, and in the material that comes with the courses, there are usually some types of date generators, and they use a loop-based approach, which makes them run slow. And to me, the code is kind of ugly to look at as well. So I'm going to show you how you can use a numbers table instead to generate time slots of variable length very, very fast using a numbers table. So let's switch over to the demo. I have declared a couple of variables to begin with. I have a start date, and the start date is March 11, 2020. That is when the COVID-19 pandemic started. Maybe a bad date to choose, but that's what I chose. And the end date, we don't know when the pandemic is going to end, so I'm going to use current timestamp, so that's now. And then I need an interval length. How many seconds between the beginning of each time slot? Well, I'm going to use 60 times 60 seconds, so 1 hour time slots to begin with. We can change this later on. Then, to support my query to generate time slots, I'm going to need numbers. So I'm starting with 10 numbers, all with the number 1. So basically just 10 rows. I don't really care about the contents of the rows, but I need the fact that there are rows. So here's a data set with 10 rows, all with the number 1. Now using this, we're going to generate 1 million rows instead. And if you have 10 rows and just want more rows, how do you do that? Well, I'm going to use a cross join. So I'm going to put this into a common table expression first with 10 as. And then I'm going to declare another common table expression. I'm going to call it millions as. And in here, I'm going to use the row number function to generate row numbers for each row. So instead of just doing select n, I'm going to do the row number function. So select row number over, and the row number function always needs an order by clause in its over clause. But we don't have an order. All my rows contain the number 1. They don't have an order, but row number will still give them unique row numbers if I just put an order by clause in. So what kind of order by clause will we use? Well, we'll order by the expression select no, or we could put anything. Select no specific order. This expression won't even be evaluated when the query is executed, but it needs to be there for the syntax to work. Otherwise, SQL Server will tell you, sorry, no can do, you need an order by clause to use the row number function. So I'm going to name this column n, and then I'm going to do a from 10, call it T1. So the 1 in the alias means I have 1 0. So a 1 with a 0 after. That's 10 rows. Cross join to 10 again. Call it T2. That's 100 rows. Cross join T3. Cross join T4. Cross join T5. Cross join T6. And I of course made a mistake. That's just the alias. So 10. Now I can show you a trick with Management Studio. If you hit Shift Alt and then mark down. You can type on several rows at once. So 10. Cool, right? So now I have a valid expression. I can do a select star from millions and see what it returns. It gives me rows. It gives me many rows. Actually, it's still producing rows. When it's done, it's going to give me 1 million rows. As we can see down here, 1 million rows. Cool. What can we use them for? Well, we can now use the date add function to generate time slots from the start date or the starting time to the end time. But I don't need 1 million rows because there are not 1 million hours from start to end. So I'm going to add up here the top clause. Top, and what kind of clause do I need? Well, I need the number of intervals. So we could either declare a variable for the number of intervals, but that would mean an extra step. So I can put it just in the calculation of it into the top clause. So we will have the date diff in seconds between start and end. And then we will divide that by the interval length in seconds. So now we have the number of rows produced. And to make sure we get them from 1 and ever increasing, we need to also add the order by n here. So let's try that again. Select star from millions. And now it's not 1 million anymore. Now it is 13,238 rows. Okay, we can work with that. And we don't want to do a star here. We want to do the date add function, and we want to add seconds. And how many seconds? Well, let's start with what do we need to add it to? We want to add it to the start date. Start. And then how many seconds do we want to add? Well, we want to add the interval length in seconds multiplied with the row number minus 1. So we will start with adding 0 seconds to get the first time slot. It starts exactly at my start time. And then I'm going to add 1 hour per row. Let's give this a meaningful name as time slot start. Then I want to have the actual row number included as well. N as time slot number. Let's run it and see what we have. We have the start, first hour, second hour starting at 1 o'clock, etc., etc. So now we have a very useful foundation for a set-based approach to generating time slots. And I can now change. I want 1 time slot per minute instead. It's going to be many more rows, but it's still going to be pretty fast because I don't read any data on disk. I don't read any data from pages. I just generate them virtually and use them. So let's run it again. Execute. It is still executing because this is going to produce many rows. But it's done. It took 6 seconds to produce and return almost 800,000 rows. That's how many minutes since the beginning of the pandemic. If we want to see how fast it is to actually just generate the rows, we don't need to return them. We can put them into a table. So let's put them into, select into a temp table and run it again. I need to write it in the right order though. Let's run it, and it's done. 800,000 time slots, 1 per minute, from the beginning of the pandemic to now. The tally table is so useful for many use cases. This is just one of them. If you want to read more about tally tables, then go to SQL Server Central and search for tally table. You will see a number of articles. One is a really fast string split function using a tally table. But there are so many more use cases. Once you get in to start using it, I think you will see that you'll use it on a day-to-day basis. Another thing to look for, just Google for it, is the gaps and islands problem. Very interesting problem to have, to find consecutive series in data and gaps between them, and group them by start and end of the consecutive series. Happy playing with tally tables. If you found this video useful, then please subscribe to youtube.com/c/transmocopter and you will see more videos coming up. They're not all going to be about tally tables, but I might have a couple more examples of use cases for tally tables for you.